what we have been doing, or what we did last time, is we took a sine cosine equation and we turned that equation into a graph, right? Today, what we're going to be talking about is going the opposite direction. We're going to be taking the graph and trying to get an equation out of it. So far, so good? Everybody okay with that idea? The tools that we're going to use to do that are going to be our definitions for like amplitude, midline, and period, as well as our formulas on how to get those from the A, C, H, and K's. So for example, we know that the amplitude is half the total height of the wave, so it's like basically the, like for half the distance from min to max. And we know that the amplitude is the absolute value of A. So if we read the amplitude from the graph, from the picture, we can figure out what the absolute value of A is. The midline is like the line that divides the graph in half. We know the midline is y equals k, so if I can find the midline, I can find k. And we know that the period is like the length of one cycle of the graph, and I know that the period is 2 pi times the absolute value of c. So if I can find the period, I can figure out the absolute value of c. So far, so good? All right, so let's look at a couple of examples of doing this, and then we'll start walking our way through how to do this, right? Let's see. Get this all situated. What's this little S here doing? Boop. All right. So here's an example. I have a graph, and what I want to do is figure out the values for A, C, H, and K, so I can write the equation of the sinusoid function that generates this graph. What I'm going to start by doing is I'm going to look at the graph and use my eyes to figure out where the midline is. Now I remember the midline divides the graph in half. So it looks to me like the midline appears to be the x-axis here. The x-axis is y equals 0. And since the midline is y equals k, we know that k is 0. So far, so good. Next, what I'm going to do is I'm going to find the amplitude. Again, I'm going to look with my eyes. I know the amplitude is the distance from max to min, or just from a max or a min back to the midline. That's probably what I'm going to use since I just drew the midline in. So for example, that distance is the amplitude. If I count up from 0, 1, 2, the amplitude I see is 2. I know that the amplitude is the absolute value of A. So that tells me that A is going to be plus or minus 2. I don't know which one I'm going to want yet, but I know it's got to be either positive or negative 2. We'll make that decision a little bit later. So far, so good. Now, the period is 1 full cycle. That's what I'm going to find next. So here, 1 full cycle, all I got is if I start here on the midline, I do an up, I do a down, and I go back to the midline. That's 1 full cycle, right? So it doesn't I mean, we'll see some more examples. When we find the period, it doesn't have to be like a midline point to another midline point. Anything that's 1 full cycle is fine. So we start here at negative 2 pi, and we end here at positive 2 pi. So like from here to here is 2 pi long, and then there to there is 2 pi long. So my period should be 4 pi. Everybody okay there? And we know the period is 2 pi times the absolute value of C. So if I divide both sides by 2 pi, I get that the absolute value of C is just 2. And so I can say that C is plus or minus 2. So I'm not going to put a box on that yet. So far, so good? Now, one of the things here is there's not just one answer. There's not just one equation that's going to generate this graph. In fact, there's going to be infinitely many equations that generate this graph. Our job is to just find like one of them. Okay with that plan? So I don't need to find all of them. And there could be lots of different answers. And we'll talk about like where some of these different answers can come from. But one of the things that will always be possible is, or one of the things we're going to have because we have infinitely many choices, is that we have some choice as to like, what do we want to assume to get to our answer? Now, the assumption that I'm always going to make when I'm doing these problems is that the C will be positive. So every single time I'm going to choose the C to be positive. Grace.
Wait, so is the period 4 pi?
Yes.
So then what's the work vector for C?
Nope. That's the formula for period that we saw before. Period is 2 pi times C. So I know that if that's equal to 4 pi, I can then solve for C. And that's the work that's underneath it. Is that okay? So every single time I do one of these problems, I'm going to assume the C is positive, and I'm going to just find an answer with a positive C. There's answers with positive C, there's answers with negative C. I don't think taking the C to be negative ever gets an easier route to an answer, but I think sometimes making the C positive certainly can make the route to an answer easier. So I'm always just pick C to be positive and I don't think about it. I would encourage you to do the same thing, although you don't have to. But I don't think it's ever going to be advantageous to do it as a negative. Okay. So we have K, we have C, we've narrowed A down to either positive or negative 2. We still need H. And we need to decide whether we want to write this as a sine function or a cosine function. Those are the 3 things left to do, right? So let's say that for the time being, let's decide we've chosen to make this a sine function. Okay with that? So what I'm going to do now is I'm going to pick a function, pick a point from the parent function of sine x. The point I'm always going to use, because again, it's going to make the arithmetic easier, is the point 0, 0. So if you remember what the graph of sine looked like from last time, it kind of looked like that. Notice 0, 0 is a midline point, and preceding that midline point, the graph has a minimum, and following that midline point, the graph has a maximum. So I'm going to note that below. But every time I do one of these problems where I'm given a graph and I'm writing a sine function, the point I'm going to choose from my parent function is always going to be 0, 0, and it's always going to be a midline max point. What I'm going to do now is I'm going to go to my resultant function, the graph that I'm given, and I'm going to choose a midline point from there. So there's 1, 2, 3 midline points that I can see. Does it matter which one I choose? No. But depending on which one I choose, my answer will look different. I'm going to choose this one that's also 0, 0. And then I'm going to look at the graph and see what kind of midline point it is. Does this midline point go min, midline, max? Or does it go max, midline, min? So I'm going to go back to my picture, and I see that before my midline point, I have a max, and after my midline point, I have a min. So I'm going to note that here below. What I'm going to do now is I'm going to compare the two types of midline points that I've chosen. Notice that my parent function goes min, midline, max. My resultant function is the opposite. It goes max, midline, min. Everybody see that? Because they are opposite orders, that tells me that the A value is negative. If they were the same order, what would that tell me? The A value would be positive. Okay? So comparing the type of point that I'm using, the type of midline point in this case, is going to tell me whether the A is positive or negative. So we've chosen the C to be positive. We've chosen to use a sine function. We've chosen a point to map to our parent function. We figured out the A value we have to have for that point. We still need to find the H, right? So let's show you how to do that. So remember when we were graphing, we noticed that if we take some point on the parent function and we apply the transformation Cx plus H, Ay plus K, that's going to give us a point on the resultant function. This is what I'm going to use to figure out what H is. So the point for my parent function I chose to use was 0, 0. For the resultant function we've built so far, we know that the C is 2. The X from our parent function was 0. H is what we're interested in. Our A was negative 2. The Y from our parent function is 0, and our K was 0. And I know this has to give me the point from my resultant function, 0, 0. So if I simplify this, 2 times 0 plus h is h. Negative 2 times 0 plus 0 is 0. So h has to be 0. Now I have everything I need to write my function. Yes, Kate?
Why would you write the h as an x value?
Because when I simplify this part,
Oh, okay.
it is h. So I'm going to write y equals a, which was negative 2, sine 1 over c, which was 2, x minus h, which is 0, plus k, which is 0. So if I simplify this down, my function should just be y equals negative 2 sine of 1/2 x. That's an answer. How could I have gotten a different answer? Well, one way could have been, instead of choosing 0, 0 as my midline point, I could have chosen negative 2 pi 0 or positive 2 pi 0. If I did that, I would have a different answer. So that's one way you might have gotten a different answer. Scroll back to the bottom. I think people were still writing. Another way you could have gotten a different answer, so you could have chosen the c to be negative. I would never do that, but you could have. Again, that would end up giving us a slightly different answer. Or we could have chosen to write a cosine function. Let's see how that would make things different. So let's say this time we chose the parent function to be cosine x. Yes?
I'm just having fun, so maybe I've never had a slip. Is it okay if I still go?
Sure. Yeah, sure. My voice cracked. That's embarrassing. Okay. Whenever I use a cosine function, or a cosine as my parent function, I'm going to choose to use the point 0, 1. If we remember back what the graph of cosine looks like, 0, 1 is a maximum. So from my resultant function, we want to choose a point that's also an extreme point. So either a maximum or a minimum, it doesn't really matter. So let's go back up and look. So we could pick either of the two. Let's say I pick this one here at pi comma negative 2. Everybody's okay? And I observe on the graph that that one is a minimum. So just like the sine function now, I'm going to compare the type of point that I have. Notice that they are opposites. What is that going to tell me then? That the a is negative. And then I'm going to draw the same function map to figure out my h. So 0, 1 is going to map to c times x plus h, a times y plus k, and that needs to come out to be pi comma negative 2. Well, 2 times 0 plus h, that's just h. Negative 2 times 1 plus 0 is just negative 2. So my h has to be pi. That's everything I need. So to write my equation, I'd say y equals a cosine 1 over c x minus h plus k. And if I simplify, I have negative 2 cosine 1/2 x minus pi over 2. And we're done. What do you guys think? The process I've shown you will be the same no matter what, which is the reason why I'm asking us or showing you guys how to approach it in this fashion. It's because all the problems now will basically become the exact same thing. Francesca? Of course. Let's do another example. Sound good? Okay, so we have a new example. I'm going to approach this in the exact same fashion. I'm going to start by figuring out my midline. Take a look at the graph. Can anybody tell me where the midline is? Just using our eyes, right? It's not, well, if you notice the y scales by halves, so I think you mean 1, but this spot right here, right? So that tells me the k is 1. Okay, so far? Again, we gotta be careful reading the scales, but I think I knew what Jacob meant. What's the amplitude gonna be? So the amplitude is here. Again, that's 1 unit. So A should be plus or minus 1. Now here I'm given lots of cycles, right? This graph is repeating itself lots of times. Usually in this sort of situation, I'm going to just go from to do the period, I would just go from max to max or from min to min because it's really easy to see those. So maybe I'll go from minimum to minimum. So if I start off at negative ½ pi and it ends at positive ½ pi, how far was that? 1 pi, right? And we know the period is 2 pi times the absolute value of c. So if I divide both sides by 2 pi, I get that the absolute value of c is 1/2. And then we're always going to choose c to be positive. Are we okay so far? Stop me if it's going too fast or if you don't understand. Miriam?
You said you got 1/2. That's where it was.
this equation here, I solved for c. So I divided both sides by 2 pi. Pi divided by 2 pi is a half. That's okay. I didn't write down the step because I just said it. But if you were like halfway there, it's easy for that to just kind of like wash over you and not make an impact. Grace.
For the midline, why wasn't it like the
Well, is half the graph above and below it?
Oh, so it's like half of the. Okay, got it.
So like, like half of it is above and then like half of it's below. So it just needs to divide the graph in half. Does that feel okay when what I mean by like splits it in half?
Yeah.
All right. Let's go ahead and start figuring out the rest of this. If we're using sine as our parent function, what point do we use? 0, 0. And what kind of point is that? It's always a minimum, midline, maximum. From our resultant function, we need to pick a midline point also. Now we have lots and lots and lots and lots and lots of choices. Look at all the choices we have. If it's me, I would pick this one here because it has the smallest positive x-coordinate. Basically, the smaller the number feels easier to me. I'd rather deal with a positive than a negative because there's a negative sign to get in the way of dropping or something and just making a silly mistake. But it doesn't really matter. Any of those midline points that I circled would be fine. The one that I boxed is pi over 4, comma 1. And if I look at this midline point, it is a maximum, midline point, minimum, right? Miriam.
How do you know it was like pi over 4? It's like really obvious.
Because I read the scale.
Oh,
It says 0.25 pi there,
okay.
which is just pi over 4.
Oh.
That's okay. It's really small from where you're at. So if you had binoculars, I would give you a hard time about it, but you don't. So, ha. What can I tell about the A value from what I've highlighted in yellow? It's going to be what sign?
Negative.
Negative.
Wait, should we do cosine?
We will do cosine also, but we're going to do the sine first. Doesn't really matter which one you do first. I just decided to do sine first, and I'm already halfway through, so I'm not going to change that now. Okay. So now let's figure out the h. That's the last step, right? Before writing the thing out. So we're going to take our parent function point 0, 0. We're going to apply the transformation c times x plus h, which we don't know, comma a times y, which is 0, plus k should give me the point pi over 4, comma 1. Again, that's my parent function point. That's my resultant function point. Everybody's good so far? 1/2 times 0 plus h is h. Negative 1 times 0 plus 1 is 1. What does the h have to be? Pi over 4. So if we put this together, I have y equals negative, or a, times sine of 1 over c x minus h plus k. One over 1/2 is the same thing as 2, right? When I distribute that 2 through, I get 2x, and I get pi over 2. So far, so good? Okay. Let's do this now for cosine. So this exact same process, except for cosine, what point do I choose? I choose the point 0, 1. And what kind of point is that on cosine? It's an extreme point. It's a maximum. Kate.
How come for sine you wrote min, like max, and then for cosine it's just max?
So on the graph of cosine, it kind of looks like that. That's just a maximum. For the graph of sine, it looks like that. But there's two types of midline points. There's ones that go like min, midline, max, or you have this one that would go max, midline, min. So you have to differentiate between what kind of midline point you have, right? And there's two types of extreme points, but the two types of extreme points are just a maximum or minimum. Doesn't matter what happened before or after it.
Yes.
The midline point, though, it matters what happened before and after. That's why we have to differentiate what type of midline point we have. Does that feel okay?
Yes. Thank you.
If it's easier for you, you could think about it as like that, where it says, okay, the graph is down midline and then the graph goes up.
Mhm.
You can think about it that way, and then it's not, you don't have mins and maxes in there twice to get confused.
Okay.
Right? If you want to write it that way, that's okay. That's kind of saying the same thing.
Mhm. Thank you.
Sure. Okay. Now, in our resultant function, we need to pick a extreme point to go with our maximum. So if I go up and I look, again, I have lots and 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 lots of choices. Which one do you suppose that I'm going to choose? I'm picking 0, 2. I want to pick the things that have the easiest coordinates possible to handle. If I can get something with no pi's and no fractions in it, sounds good to me. By the way, when I looked at the graph, what kind of point was 0, 2? That was also a maximum. So if I compare these two types of extreme points, what can I say about the A in this problem? It's positive. Because they're the same.
Did we get the 1 from like what we solved for?
Yeah, because A was plus or minus 1 when we looked at the graph, right?
Wait, how do you know if it's negative or positive?
So these were the same,
Oh.
so they're positive. These ones were opposite, that's why it was negative. Cool? Okay. And then we'll do the same thing we did before to find h. So we're going to take the point 0, 1 from our parent function, and we're going to transform it by doing c times x plus h, and then a times y plus k and that needs to give us the 0.02. Well, 1/2 times 0 plus h is h. 1 times 1 plus 1 is 2. So what's that telling me my h should be? 0. So here we have y equals a times cosine 1 over c x minus h plus k. Or if I simplify this down, I just have y equals cosine 2x and then plus 1. What do you think here? Going to give you one more. This one, I'm going to give you the picture and I'm going to put 10 minutes on the clock and ask you to get as far as you can in that 10 minutes. When that 10 minutes is up, we'll go through this as a group. But go ahead just on your separate sheet of paper or in your notebook or on your OneNote or whatever. Just do as much as you can. If you finish in 10 minutes, excellent. If you get hung up eventually, that's fine. Hopefully everybody can get the midline, amplitude, and period out of this thing. I think that should be realistic. And I'm going to eat my yogurt from lunch that I didn't get a chance to. Here, I just synced my notebook right now, so if it's not showing up on your end, it should here in just a second. If you wanted to look at it on your OneNote. Yep.
Oh, wait, no, see you. I was like, that's so fitting for you. How do I find it? It really suits him. You're gonna have to watch it. Oh, yeah. See, I don't have that. Scroll up. Yeah. So my tablet doesn't have any of like the dates, like find the homework and.
It's because you have these errors
Oh.
that are preventing you from syncing.
Oh.
So this guy doesn't know what to do. It has this error on it, which I think is probably jamming up everything else. So let's do this. Oops. I'm going to close this book, and I'm just going to open it back up. I'm going to push a sync and see if that clears your error. Did you ever use your own personal notebook?
Oh no, that can like be deleted.
Oh, I don't think you can delete it, but let's close it and see it. Uh-oh, what's that? That was the 10-minute timer. Yeah.
Oh, I thought they were like.
You're supposed to. I was
You're in your notebook where you copy the entire content library in there.
Oh.
That's not going to show any updates. You have to go into the actual content library.
Oh, so then I can do everything in here now?
No, you don't get to write in here, but you can see everything in here.
Oh, so then I can copy it down on paper.
Or you could copy it
over.
into the
Is
other
that where I
note.
double click on it and put move?
Or you can just like copy
Oh my gosh.
here and then just paste in the next one.
Oh, thank you.
But, yeah. All right, let's run through this. All right, so who said the midline was 2? If you did, that's great. Who said that the amplitude was 3? So our A is plus or minus 3. Now this would be our period. We're going, notice that there's 1 tick mark between 0 and -1/4. How far is a tick mark then? 1/8, right, yes, half. Yep, so I have like -1/8 to positive 7/8. Basically, if I count the boxes, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 eighths, which is how far? 2 pi, right? So we know 2 pi absolute value of C is 2 pi, so C is just 1. And again, we're choosing it to be positive. So far, so good? Some people were like, yeah, I got that right. That's great. That's okay if that's as far as you got. That's a good start. No, I just have good ears. So from the resultant function, I'm going to pick a midline point. So one of those, I think I'm going to pick this one in particular, which is 3/8, 2. If I look at that, that goes minimum to the midline point to the maximum. So that's going to tell me that my A value should be positive 3 because they are the same kind of midline point. If I'm going too fast or if I did something you don't understand, please stop me and interrupt.
Is it fine if we just left it like 0.75?
You mean 0.375?
Oh.
Yes, but I will write them as fractions on your papers that I give you. It's just generating the example. I don't have a control over that amount of formatting. Then we go take my parent function point and transform it by doing C times X plus H, and A times Y plus K. And that should give me the point 3 pi over 2, or 3 pi over 8, 2. 1 times 0 plus h is just h. 3 times 0 plus 2 is just 2. So my h is 3 pi over 8. So I'm going to write y equals a times sine of 1 over 1, or 1 over c, x minus h plus k. Or if I simplify this down, just 3 sine of x minus 3 pi over 8 plus 2. Yeah, certainly. Or if I had chosen to do this as a cosine, again, we always pick the point 0, 1, which is a maximum. From our graph, I need to pick an extreme point. I don't know, I'll pick this one here. So that's negative pi over 8, comma, negative 1, which is a minimum. What does that tell me about the a value? Negative. So we're going to take that point from our parent function and transform it, doing c times x plus h, a times y plus k, and that needs to give me negative pi over 8, comma, negative 1. Well, 1 times 0 plus h is just h. Negative 3 times 1 plus 2 is negative 1. So h has to be negative pi over 8. And then we plug it in. So a times cosine 1 over c, x minus h plus k. Or if we simplify this, negative 3 cosine x plus pi over 8 plus 2. And it looks so easy when you do it, Mr. Kulik. I know. It takes a minute to get the hang of it. Once you get the hang of it, though, they're like kind of all the same. So for your homework, I want you guys to do worksheet 3. So in worksheet 3, you're going to be given some graphs and ask you to write the answer in both a sine and a cosine. There's just 4 graphs. So I know that'll still take a minute because it's not trivial for you guys doing this process right now. I understand. It takes some practice. So as a reminder, what's due on the Sunday's problem check? No. Chapter 3, worksheet 1. So the graphing, sines and cosines worksheet that we assigned last time, that's due Sunday. This is due a week from Sunday. Okay? So again, not a rush to get this one done, but like, start it now, because we're done for today. The next 20 or 25 minutes, I'm going to give you guys a chance to work on this, because I know it's not trivial for you, that you need to have some time where you can try and ask questions and get stuck and talk to one another and talk to me and kind of make some progress here before you have to try it on your own. Okay? Everybody happy? Clear as what's due when? Okay.